Thank you, Claire, and thank you, Stephanie, and good morning, everyone. And it's really a pleasure to be here. Yesterday I had the pleasure to visit the Black Rock Castle, and it was really nice. And I decided to include a castle also in my presentation. I grew up in a castle. Actually, I'm Portuguese. I grew up in Castelo Rodrigo. It's a castle by the border with Spain, just on the other side of the Porto. Porto is on the coast. Just draw a line to the border, and I'm from there. That's where I grew up. And I had the pleasure to have access to a beautiful night sky, and that's why I got really interested in astronomy. But of course our castle was also there to protect us from the Spaniards. It seemed that the castle here was also used for that. They were all over, attacking everyone. But now I work in an observatory, another connection with the Black Rock Castle that now also hosts an observatory. I work in the Netherlands. I work at Leiden University, which is probably hosts or has the oldest university observatory in the world. This building that you see there is one of the landmarks of the city. It's a building from the 18th century. But the first observatory at our university was established in 1633. And if we think that Galileo used the telescope for the first time in 1609, a couple of decades later, they already had an observatory to teach astronomy at university using an instrument like the telescope. So we are very proud of our beautiful heritage, but also our beautiful observatory. And now is one of the largest astronomy departments in Europe. There's around 300 astronomers, from PhD students all the way to faculty, trying really to understand how the universe works. And I'm really quite lucky to be part of that team. And I think it's clear that if you have access to a very dark sky and you look at the beautiful Milky Way, you get kind of certain fascination for the universe. You start looking at all those bright dots and start wondering, what are those? And the history of trying to make sense of the universe is quite old. It's almost as old as humanity. And of course, New Grange in more than 3,000 years ago is a very good example of this attempt of our ancestors to make sense of the universe, to trying to understand what's going on. This incredible construction has a lot of connections with astronomy, and I'm sure that all of you have visited. I didn't. I'm really curious about it. I have to go there. But I know about this particular place as one of the most important places for humanity in our, like I said, attempt to understand the universe and to make sense of all the different motions that we see in the night sky. But the story that I want to tell you today starts 3,000 years before. Actually, it's around 7,000 BC, and also starts in Portugal. Well, because I'm from Portugal. And it's about some rock art that you can see in an open cave, kind of an open space that you see in the northern part of Portugal, where some archaeologists working on this a couple of years ago, they found some interesting rock art on the walls of this open cave. And when you start looking at them, they can start looking at some interesting objects that they saw and they found. And if you look at your right-hand side, you can see something that is kind of shining. Can you imagine something that, what can that be? Maybe the sun. Maybe the sun, most probably the sun. And then on the left-hand side, you see also something a bit more, you also see something like it's shining, but then there's two things coming out from that shiny like circle. Can you think about a celestial object that could be
a meteor?
A meteor, could be a meteor, a comet. Someone said a comet, and the archaeologists start thinking about that might be actually a comet. And then they ask some colleagues from the astronomy department of the same university to figure out, do you think that this could be a comet? They start looking at the different possibilities, and comets, as you know, are these strange objects. They are like these pieces of rock, sometimes quite big, that go around the solar system. And from time to time, they come back to the inner solar system, and you can see them on the night sky. They look like these very bright objects that sometimes can have these very long tails. And they can really be really bright. We had some bright ones a couple of years ago. And they look a bit like this in the night sky if you look through a telescope. And you can see some of the tails coming off the comet. So they run the different comets that we know through a model, and they try to identify if it was be possible to have one of these comets on the night sky 7,000 years ago. They could date the rock art, so they knew that it was around 7,000 years old. So then they're trying to understand if there was a bright comet that could be around that time, around those decades on the night sky, and they found one. So they know that around that time there was a very bright comet that was on the night sky in that particular area that could be seen from that place where they did this drawing. It's fascinating, right? We're talking about something that was 7,000 years ago. But to me, what is fascinating is that after 7,000 years, we humans, we Europeans, managed to not only understand what is a comet, but build a machine, a piece of technology, and send it to one of these comets. I'm talking about one of the most fascinating missions of the European Space Agency. It's called the Rosetta mission, that was launched from Earth to go to a comet, to start orbiting the comet, but also to land on the comet to study the comet in detail, to understand the surface, to understand kind of chemical and elements, molecules that we can find. We also know from science that comets are very important for us to understand the origin of water on our planet, and we know how essential is water to understand life. So that's why studying comets is very, very important. This mission was very successful. Studied this comet called Churyumov-Gerasimenko. I think it's a Ukrainian name, if I'm not mistaken. And it was a mission with a spacecraft they call Rosetta that was pretty big, but I'll say maybe 1/5 or 1/6 of this room. So that was the size of the main spacecraft. And then had a smaller thing called Philae that was the size of a washing machine that tried to land on the comet, and actually managed to land. Was kind of a difficult land. It's not super easy, but the mission studied in detail the comet. This is the size of the comet. As you can see, it's a piece of rock that has the size of a city like Amsterdam, so it's pretty big. It's a big piece of rock, and this space mission studied in great detail, and also managed to take some pictures from the surface of the comet. There's different types of comets. And the typology of comet depends on the chemical composition of the comets. And for this particular one, we really wanted to understand what kind of molecules we could find. And we're trying to understand if this could be the type of comets that could have water, and would be the type of ones that brought water to our planet. And that's what we ruled out. These type of comets are not the ones that brought water to Earth. So now we need to go to the other type and study those to see if they have water or not. So we know that these types don't have. That was one of the major findings of this mission. And but now we need to study others. But it was very, very fascinating mission. I think we all agree that space and astronomy has this major appeal for several reasons. I'll say that one of them is because sky is really accessible to everyone. Things changed in the last century, mainly, because of the electricity. Now we have public illumination, so we have street lights all over the civilized world. So we kind of lost a bit this access to the night sky, and that's why there's so many initiatives now to protect the dark sky and to protect the night sky, because most of the people living in cities, they don't even know how the Milky Way looks like. Have you guys seen the Milky Way? Who has seen the Milky Way? Okay, a large majority. I guess here you are not so far from the countryside, and when you go out in a clear night, when you don't have clouds, like today is a beautiful day, gorgeous day. So you have this, you can see the Milky Way, and it's fascinating. I think we're also quite lucky that our science, astronomy and space, has access to these beautiful images of the dark sky, of the night sky, and of celestial objects. They are really beautiful, galaxies, planets. They're really amazing, and they're very attractive to the public because it kind of helps us to imagine these kind of different places in the universe. Of course, this excitement around space exploration, space travel, astronauts going to other places, seeing the Earth from space, looking at living on other planets is really, really interesting. And one of the most popular topics, especially for school children, is this idea of life in outer space. Alien life. Is there life on other planets? Is there life in the universe? So this is one of the most fascinating topics. We also know that space and astronomy is connected with so many different areas of knowledge. And not only in the culture and society that I've been talking, but also if you look at technology in the industry and science and research, there's a lot of connections between astronomy and other disciplines. And if we're going to be talking a lot during the rest of the day about all these connections between space and astronomy with the different subjects in school, and you can see there's a lot of connections, not only on the typical ones that will be the STEM fields, but also in culture, society, and of course quite a lot of connections also in technology and industry. I saw that you at the Black Rock Castle, you have this image on the wall, right? I think it's a very...
And also how strongly it relates to the Sustainable Development Goals.
Exactly. That can contribute to some of the Sustainable Development Goals. Exactly. There was actually an interesting study done in 2010, so it's almost 10 years old, and we like to present this study because it kind of demonstrates how important astronomy is for education. This is a study done by some colleagues in Norway, and it's called Relevance of Science Education, and pretty much the study is very simple. They wanted to know what would be the most interesting topics for students about science and technology. What would be the main topics they will be interested on. And they did this study across different countries all around the world, including Ireland, actually. Can you see Ireland over there? And they asked the question, what is for you the most interesting science topic in school? And in Ireland, if you look at the data, I think it's around 70% of the kids, boys and girls, they said that space, life in the outer space, was the most interesting topic for them. So around 70% of your students, it seems, they think that space is the most interesting topic in science and technology. Maybe you can correct me if I'm wrong, or at least if this study is wrong, but this is kind of demonstrates how relevant is the topic of space as an entry point for science and technology in the classroom, because the kids are really interested in this topic. And like I said before, I think it's clear that why we are interested. Because the sky is really beautiful and the night sky is really fascinating. I started talking about the Milky Way. And the Milky Way, it's our galaxy. We live inside the galaxy. And at the moment we have a mission from the European Space Agency called Gaia that is trying to map the position of the stars in our galaxy. So all those bright dots that we see in the night sky, trying to map them, to calculate, to measure the distance from the Earth to these stars. So we can have a comprehensive map of our galaxy. So in a way, it's trying to understand what is our position in our galaxy. So this mission is measuring, scanning the sky. So it just rotates and takes a lot of images and try to compare the different movements of the stars when we look at the stars in different times, and through these small differences measures to a very complex, not so complex actually, through parallax measures the distance to the stars, and then measuring it at that distance we can then create a real quite detailed map about our own galaxy, the Milky Way. Since we live inside the Milky Way, we don't have a picture of our galaxy from the outside. But our galaxy will look somehow very similar to something like this. Not exactly like this is a picture of a real galaxy, but our galaxy will look something similar like this. With a bright core, the center of the galaxy, with a black hole, a supermassive black hole, and then we'll have stars rotating around this black hole. You see some of them, all the bright dots, and in our case as well, we'll have these spiral arms going out from the center of the galaxy. So it will be a spiral galaxy, and will be our solar system will be somewhere like maybe 2/3 from the center of the galaxy in direction of the outside. That would be our location, like in the outskirts. It's like a completely not so special place, not really a very ordinary place to live in our galaxy.
It's in Ballincollig.
Is it? Maybe. So this is where our position in our galaxy, and also what's interesting about when we study our galaxy and we study other galaxies, we also understand this. We also study the stars in the galaxy, and we realize that our star, the sun, is also nothing special. It's just a very ordinary star, which has some planets around them. This is let's say, the family picture of our solar system, with the sun and all the other planets, the small ones that we call the terrestrial planets, and the bigger ones, the ones outside, they are called the more gaseous planets. So like they are much bigger atmospheres, and of course we have big planets like Jupiter or the beautiful Saturn. And but in the last years we start discovering something that is really fascinating. And I like really to use this analogy that was kind of presented for the first time by a quite famous astronomer and science communicator called Carl Sagan, that starts saying that there are more stars in the universe than grains of sand on the coastlines of our planet. And I think this picture is from a place not from far from here, right? I think it's Barley Cove or something like that.
Yeah.
And if you go there, and if you kind of just grab some sand from this beautiful place, and imagine how many grains of sand you have there, the amount of sand that is on this cove is really incredible. Now imagine all the coastlines of the whole planet, and imagine how many grains of sand you can find. So we know there are more stars in the universe than that number of grains of sand. And that's it's difficult to even understand and to grasp that concept. But for me, what is even more fascinating now is that we know that most of these grains of sand, these stars, they have planets around them. Most probably, the large majority of them will have small planets that will orbit around these stars. So now imagine the number of stars, these grains of sand. Most of them will have planets around them. Now imagine the number of planets out there, the number of exoplanets, these planets that are outside our solar system. We call them exoplanets. And as of today, we know more than 4,000 that we have confirmed that they exist in our galaxy. So if you look at our galaxy, we already confirm more than 4,000 exoplanets. And this has been a major revolution in astronomy. It was so big that this week, the Nobel Prize for Physics was awarded to two of the astronomers, Michel Mayor and Didier Queloz, that they discovered the first exoplanets back in 1995. A couple of decades ago. It was not so long ago when we managed to discover for the first time one planet around a star that is not our own star, the Sun, these exoplanets. And this discovery is so important that they now receive this Nobel Prize. The other one received also the Nobel for an important aspect of astronomy called about dark matter and dark energy, about cosmology, about his massive contribution to the field. But I'd like to focus today on the exoplanets. And these exoplanets have been really very important for astronomy in the last years. So important that this year, during 2019, we're running a campaign all around the world that we call Name Exo Worlds. So I've been inviting countries from all around the world and the International Astronomical Union to give them the opportunity to name one of these planetary systems, the star and the exoplanets. And I have the picture here, or not a picture, but it's an illustration of how potentially the one for Ireland looks like. This is at the moment has this funny name, HATP36b. So like I was saying, we know confirm more than 4,000 exoplanets. We know that there exist many more. And I think at the moment, what you are really trying to find is an exoplanet that maybe will be similar to our own planet, that will be at the right distance from the star, will not be too far where water might be just ice, will not be too close to the star where water might just evaporate. We're looking for a planet that might have a surface, a rocky surface, might have an atmosphere, and might be at the right distance where we can have liquid water, right distance from the star. And we call this the habitable zone. This is what we believe that is the right area around the star where we can find planets with these characteristics. And if we find them, maybe we'll find life. And that's one of the main things that now in astronomy are working, is trying to find a planet that will be similar to our own planet, Earth. So that's why in astronomy, we build these telescopes to try to study in more detail the stars, the galaxies, but also to try to identify this, or trying to study in detail these exoplanets. This is the telescope. It's called the Very Large Telescope. They are quite large telescopes in Chile. They have the mirror of this telescope is around 8 meters, or slightly bigger than 8 meters. They're quite big telescopes, much bigger than the one that you can see here at the Black Rock Castle. And they've been operating in Chile for quite some time. They are part of an organization called European Southern Observatory, and Ireland is actually also a member of the European Southern Observatory. And they've been building and operating these very large telescopes, because they're pretty big. Now, with these telescopes, we can identify these exoplanets, because we can see going them around the star, and then you see the brightness of the star changing, and because of that brightness variation, we know that there's like a planet passing in front of the star. But if we want to look at the exoplanets directly, we need to have a bigger telescope, much bigger telescope, and that's why we are building a new telescope. And just as a comparison, you see here the Arc of the Triomphe in Paris, and you see the 4 very large telescopes, and then we are building the next big one. Can you help us name it? Can you imagine what's the name of that largest big one? Very large telescope. Almost. They decided to call it extremely large telescope. So at the moment, and I'm not joking, that's the official name. So if you want to find more about this telescope, you have to Google extremely large telescope. They are now building it. It's going to be working maybe anything between 8 and 9 years from now. The construction has started in a mountain just across where the Very Large Telescope is, and it's the extremely large telescope. And it's going to be 39 meters. It's going to be like these tiles, mirrors that all together they'll make a quite large mirror. And with this telescope, we'll be able to study the atmosphere of these exoplanets. We're going to be able to look directly to these exoplanets, and maybe we'll find interesting molecules in the atmosphere that they might be connected with the existence of life or other processes in these planets. So it's really fascinating. The European Southern Observatory also manages for Europe these radio telescopes, but also these are the ultimate radio telescopes, because in astronomy the objects that we study are really far away. Sometimes we can go there, sometimes we can go to the moon, we can go to Mars, sending rovers going around. We can send spacecrafts going around some of the planets of our solar system, like Venus, Mars, Jupiter, Saturn. But sometimes most of the objects that we study are so far away that it will be impossible for us to send spacecrafts there. So what we do, we study them from the Earth or from space with telescopes, like the Very Large Telescope or the Extremely Large Telescope. But usually those telescopes will observe in the optical, like usually the type of light that we can see with our eyes. But we need as much information as possible, and that's why we also try to observe the universe in other wavelengths. And an important wavelength for astronomy is radio. You know, the same wavelength when you have to tune your radio to listen to the morning news. We try to get the radio signals that they come from these objects from the sky, and that's why we build radio telescopes. This is the ALMA, but for the last 2 years or even 3 years, Ireland is part of a network of radio telescopes around Europe called LOFAR, and we're going to have also a workshop later today, or in the morning and the afternoon, about the ILOFAR, Ireland LOFAR, and is a large network of radio telescopes in Europe. So I would like to have this interlude now. So we're going to call it fictional, so it's not about real science. It's like a science fiction moment of my talk, and I hope that you can all participate. So we're going to create a scenario here. It's going to be a really fictional scenario where we're going to imagine that one of these radio telescopes that I mentioned received a message from an extraterrestrial source, most probably life form. So like I said, we have these radio telescopes, and this is real, that listen to the universe to study different objects. And we also have some radio telescopes that are trying to listen for some messages or some signals that will come from an alien civilization. So now imagine that we actually received this signal, and we also can confirm that this signal, there was a message that was sent from these exoplanets, and we received it in our radio telescopes. And we actually don't have any proof that that message that they sent it to us. We just received it. You know, it's like when you tune the radio, they're not necessarily talking to you, right? They are sending all the radio waves into space. And I'm going to show you what was the signal that we detected. This was detected signal. So after we ran some software, we managed to detect this, to see that was the detected signal. We don't know what it means, so maybe we have to start there. But before we try to understand what is signal, we also need to decide if we're going to send a message back or not. So that's going to be our task for the next 2 or 3 minutes, is to decide if we should send a message back to this exoplanet system from where this message came. But before we answer and before we have a discussion about that, I'd like to give you these quotes from our dear... This is a real quote, and it's from, I guess, BBC, and where he said that meeting an advanced civilization could be like Native Americans encountering Columbus. That didn't turn out so well, as we know. So now we have a dilemma. So we are in this situation where we got a signal that is from a confirmed exoplanet system. The signal seems to be sent by an advanced extraterrestrial civilization because they have radio capacity, so they can send radio signals. And there's a danger that if this civilization, it's a dangerous civilization, that they can come, if we answer, they can know that we are here, they can come, locate us, and attack us. So I would like to have a discussion. Should we send a message back to this planetary system?
Yes. Yes.
Oh my, that was fast.
No.
So, okay, we have some no's and yes. Who would like to share their thoughts on this?
No.
Why no? Tell us. maybe you think.
There's so many no's. There's so many reasons.
Give us some reasons.
What's the point? They're going to get it in 40, 50, 60 years at the speed of light. They have to, and they're going to send us back in 40, 50, 60 years, and we're doing this for free? No. We do a, hi guys, want to know some fabulous tourist information about our planet. What are you going to give us? Why are we doing it for free?
So we have to decide if we do it for free or not. So before let's I want to hear some arguments like in favor of sending a message. Is that
We put a gold plaque on Voyager 1.
I know.
Why? Purely to let people out there, if they're out there, know that we're here.
so? Also, Khalil was saying that back in the 80s there was this mission called the Voyagers that they actually designed this what they call the Golden Plague, and they put it in the spacecraft, so with actually the location of the solar system in quite detail. And this spacecraft is still flying, so maybe an alien civilization will find it and will have the treasure map how to come to Earth and steal all our water and or maybe gold, who knows? So that might happen. I want to hear some arguments against sending this. You have an argument against? Please.
Maybe we don't want an alien civilization to know what we're like, because they'll consider us primitive and not more stable.
No, but maybe if they consider us primitive, they will come and enslave us, and there will be their. That happened in the past, so that might happen. So they might be actually quite keen on finding us, some free labor.
Especially if Hitler's television signal has actually progressed as it.
That's
frightening.
so. Some arguments in favor of sending a message.
Why not? Like, why explore other parts of the world? Why explore other parts of the universe? Improve our knowledge, improve things for further generations. Just because it takes 60 years, does that mean you should never plant a tree?
So your argument is right. We need to know more, right? I mean, we've been contacted.
Knowledge for knowledge's sake.
Exactly.
Maybe we probably are inferior to anything we'll find, but it doesn't mean we shouldn't look.
That's,
That improves the
let's please tell us.
Did that exploration improve the locations and the people who lived there and the environment that was there?
Yeah. So some.
Not always, but maybe we've learned from mistakes.
Any other arguments?
How can we decipher what the message is?
Please.
Well, we have to think really long term because eventually our sun is going to burn out.
So years.
No, I know.
Too worried about
Yeah, no, I
it.
know. But we have to. How long is it going to take us to figure out?
It's more likely that we'll destroy the Earth first.
Well,
Yeah,
whatever,
exactly.
but exactly, do we need somewhere else for us to live?
We never get there.
Yeah.
Simple as that.
So.
Well, we don't know. We don't know how far it is.
So I don't think we don't have that much time to discuss, but we can have a vote. So I don't think we're going to try to decipher this message now, and but maybe let's have a vote. So who is in favor of sending a message back to this planetary system? Who is in favor? Oh my. And who is against sending a message? So there's a big group that is undecided, but I think we have 50-50. We might need to convene another conference just to decide on this and to send back the signal or not. So I've done this a couple of times.
Could we bounce the signal from somewhere else and see what happens?
This is exactly. Let's do the following. We send a spacecraft to Jupiter, and we send a signal from there. And then, if they destroy the planet, they can destroy Jupiter. Right? That's a very good approach. So. This is an interesting debate. I've done this with some classrooms, especially with the high school kids, and works really well. And it's interesting because you can bring a lot of different knowledge about technologies, about communication, but it's about exoplanets, but it's about ethical debate. It's an ethical debate. It's about bringing different components. What is interesting that didn't happen in this group, in the high school kids, when I've done this, most of them, they said we should contact them because maybe they are more advanced and they already found a solution for climate change, which is of course very interesting to see how they think about their future and the connection that they can bring in about this need of knowledge to solve the problems that we have here. So it's a very simple exercise to do with your students, and it's a very interesting one because you can do it from the philosophical angle, you can do it from the scientific angle, and it's an interesting one. And most of the students, they say, yes, we should contact them. We want to know more, which is kind of also quite nice. So the signal that I was showing is actually a signal from a quite famous science fiction movie. Maybe if you are into science fiction, you saw it. It's a movie called Arrival. It's a wonderful science fiction movie from 2016. I highly recommend. And then you can try to figure out what actually was that message. And it's a typical science fiction movie. It's more about communication between aliens and humans than anything else. So it's and the main character, the actress, she's an expert in linguistics. So it's more about communication than other aspects of the science than science fiction. So let's go back to my talk and back to non-fiction and reality. And of course, I can't have a talk in 2019 without talking about the moon landing and the celebration of the 50 years of the moon landing. Especially with the first humans on the moon and walking on the moon, that happened in 1969. I know that here in Cork there was a series of celebrations about the moon landing. But also, I would like to focus on something slightly different. And back in 1969, this was a typical computer. This is the computers at the time. They looked a bit like this. They will take a whole room to do any, sometimes quite simple computational calculations, and will be as big as a room. Of course, to land on the moon is a quite challenging exercise from the technical perspective and from the technical point of view, and also in terms of computation and trying to define orbits and landing approaches, and so it's quite complex. So there was a massive need to turn in these big computers into something that will be much smaller, that will fit inside the module of the Apollo spacecraft. And actually, this was the computer that they had on the moon. Much smaller. Of course, we'll do all the calculations that they needed. And you can see the size of the buttons, and some of them, they use them quite a lot. And this was the kind of the space control computer, the central computer of the whole spacecraft. And you can see they moved from something that will be maybe as big as this to something quite small. And this was a massive improvement in terms of technology development, because this attempt to make things smaller later on led to this possibility to have computers that will be the size of a small desktop. And this was one of the first computers that was ever commercialized, so you could buy it off the shelf. And a lot of the technology that was developed during the Apollo program, especially on trying to make computational power into smaller gadgets and technology, then led to the personal computer. And that's something, this is kind of story sometimes we don't hear about it, is this idea that when we explore the universe, when we go to other planets, we need to develop new technology that sometimes, many years later, sometimes even decades later, are used by all of us. And this is interesting because a lot of times people ask, why are we spending so much time on studying planets, on studying galaxies, on finding exoplanets? Of course, I think the discovery by the sake of discovery is worth it, but sometimes the advancement of technology is so big that will pay off in the long run. Another good example is GPS. This is actually a quite interesting jump, because this small mobile phone is much more powerful than this one, and of course much more powerful than this one and this one. So there's also, this is a much more powerful piece of machine in such a small space than the first computer. But maybe some of you, maybe you are from Cork, so you know your way around, but I'm sure that some of you, they use GPS today to get here. And I'm sure that most of you didn't realize that you're using space technology to get here, right? Because for you to know what's your location on Earth through this device, or Google Maps, or any type of different maps, you need to have satellites flying to tell you, to send you a timestamp that then the thing will calculate what is your position. So you're using space technology. And a lot of people are using this space technology without knowing that this is actually connecting directly with satellites, that you get a signal from satellites. This is our GPS satellite looks like. It's, at the moment, the most advanced system is GPS. It's run by the United States, so it's an American system. And usually you need to have 3 satellites. Your mobile needs to receive the signal from 3 different satellites to know what's your position on the surface of our planet, and then it will know with quite some precision where you are. Now at the moment, the European Space Agency is working on developing, or it's already some of the satellites are already flying, and there's already some use cases for this, and this is the Galileo satellites. And the Galileo is a new GPS. It's going to be the European GPS. It's going to be managed by the European Union, and it's going to be much more precise and accurate. So it's going to be very interesting to know what kind of applications we can actually design with this system. And it will go completely independent from the military, because GPS is run by the US military, and it's going to be a civil system, so it's going to be very interesting. We in astronomy, and this is really already my last slides, when we start using photography to study the universe, we start taking these big pictures of the night sky. This is an example of an astronomer looking to some galaxies. But there was a massive need also from astronomy to capture light, to capture the light from the stars, to capture the light from the galaxies. So they start developing some of the technology that then led to making digital pictures. And at the moment, for example, the cameras that we use in astronomy, they look like this. This is a 268 megapixel camera, so it's a massive photographic camera, much bigger than a normal camera, and we can take beautiful pictures like this one, this Orion Nebula, and these are beautiful images that is taken with a camera as big and as detailed as the one that I was showing you. So, because of these needs from astronomy to take these pictures, we start developing the digital technology to take images. And we develop what we call now the CCD, which is the electronic piece that enables us to capture photons and make digital pictures. And what's interesting is because astronomy really pushed the development of these CCDs. And now we know that we have CCDs in pretty much every single mobile. Some mobiles, most of mobiles nowadays even have 4, 5, or 6 CCDs. I think the new iPhone has 3 or 4 cameras. I don't even know. It's like it's becoming, and this technology that you have there was developed because there was a need from astronomy to take digital pictures, to take digital images of the night sky. So now every time that you use your mobile camera to take a selfie, think, oh, I'm taking a selfie because of astronomy. And it's a nice legacy of astronomy. To finish, I would like to also to finish with a picture, and this is kind of in a way almost a picture of ourselves. This is a picture from one of the Apollo missions. This actually was Apollo 10, if I'm not mistaken, and they took these beautiful images of what they call the Earthrise. And the Earthrise is a picture from the moon where you see the Earth rising, and you see the horizon of the moon, and this is a beautiful picture. And this picture is so important, not only because it's humans going that far and taking a picture back, but also shows how beautiful our planet is and how rich it is. But at the same time also shows that it's very fragile. It's a planet that when we see it from space doesn't have any borders. It's a planet that it's mainly oceans, and also we need that atmosphere to live. And this was a picture that was essential for the beginning of the environmental movement all around the world. This image was used, especially the Earthrise image, was used as the kind of iconic picture to look at us as one planet, one humanity, that we live together in this planet. And that's a very powerful message. And it's a powerful message that I think we need to bring back now that we have these big, again, environmental movements around the world. And I think we need to use the power of astronomy and the power of perspective that we have from astronomy to help us to change the way that we are living together on this planet. So I think that's why astronomy can really also contribute to that, to give us a different perspective. And that was the final thing that I want to say, that astronomy has major implications in different aspects, from technology, science, but also in social aspects. And I think that's why it makes astronomy in space so powerful to use in the classroom. Thank you.